So taking a deeper look at model validation, the definition that I like is the following. So validating user input against a certain criteria before processing it. All right, so it makes sense. We get some data from the user. We want to make sure that it is valid and legit. Like we said, we want this type of validation to sit either in the presentation layer. So when we take the data from the outside world and convert it to the representation in the core of our application, which is the application and domain layers, we want it either to sit there or really over here on the border, the entrance of the application layer, making sure that the data is legitimate before we process it in the application layer. Now, going back to the user example, the question is, should we or should we not split the age validation into two separate validations? So the answer is that there's no definitive answer, because in some domains, this check will have to be in the domain layer. But in my opinion, the faster we fail, the better. I don't want to waste CPU cycles passing through the application layer up until the domain layer, creating the user and failing over here, when I can already fail in the presentation or application layer and tell the user that the data that they inputted is invalid. So again, it's not definitive, but I like failing as fast as possible. So if I can take this static validation of making the ages over 18, if I can take this static validation and put it earlier upstream, that is what I prefer to do. Now, you may be asking yourself, okay, so if we take this validation, we put it earlier upstream, what about always valid domain model? So this is a principle that we talked about, where we want to construct domain objects in a valid way. So we never need to question whether or not the property or the object in general is in a valid state. So if we do the validation earlier upstream, do we want to revalidate the age property also over here? So the answer is generally yes. So we want to make sure that the user object is constructed in a valid way. So for this, we have two general options. The first option is simply throwing an exception over here. So since we already did the model validation earlier upstream, then at this point, it is unexpected that the value will be under 18. And if it is, we can simply throw an exception. If we reach the state, then it's unexpected. It means we did something wrong and we want to monitor these cases. And the second option is creating value objects. These are objects that wrap primitive types, and they can be constructed only in a valid way. They sit in the domain layer, and once they're created, you no longer need to make sure that the data is valid. So, for example, we can create a user age value object, and this will contain the underlying age, but this object will only be created when the age is over 18 and under 120, for example, and then we'll receive it in the constructor, and we no longer need to do any checks on it. Now, in this specific case, then this is what I would go with, because creating a value object is a huge overkill, but I do want you to be familiar with this. It does come in handy many times when we have things like location. So we have also the address, also the latitude and the longitude. And once we construct it in a valid way, we have that validation done once early upstream, and then we don't need to revalidate it every place where we're assigning these values. Now, please note that this means that we'll have some of the validations twice. Some model validations that we'll do will also be done later when constructing domain objects to make sure that we're constructing the domain objects in a proper way. So the actual validation will happen twice, but they serve different purposes, and the way the application behaves when we fail the validation is different. If we're failing the model validation earlier upstream, then we'll return to the user the details of why the input data is invalid. And if it's further downstream, then this is something that's unexpected, and we throw an exception and we fail in that case. Okay, so same validation, different purposes and different reasons why we're doing the validation. Now I want us to take a look at how we can use the popular Fluent validation library to go ahead and write validation rules in a Fluent way, and why it sits very nicely in a clean architecture structured solution. Fluent validation is a very popular NuGet package written by Jeremy Skinner, and it allows us to write validation rules in a fluent way. So over here we have the definition from the GitHub repository. Basically, we can use the Fluent interface that we have and Lambda expressions for building strongly typed validation rules. So this over here is not trivial if you've been using attributes for model validation or something like that. So let's jump right in and take a look what one of these validators can look like. So as you can see, we're implementing the abstract validator abstract class, and we're specifying over here the type for which we're writing the validator for. So over here, we're writing a validator for the user domain object or C# class in general. And over here, we're using a Lambda expression to specify which property we want to validate. Then over here, we have various methods depending on the type of the property that we can invoke and make sure that they pass the specific rule. So over here, we need to make sure that this integer is greater or equal to 18. Now, the beauty is that once you have such a validator, then you can go ahead and simply create an instance of it, call validate async and pass it such an object, and then you get a validation result that if it is not valid, then you have these validation errors. Each one of the validation errors contains a descriptive description of what went wrong, which property was invalid, and what are the values that it was expected to have. This way, you can propagate it back to the user and they get a descriptive error telling them that they provided 12, but the value should be 18, okay? So this is very powerful and it makes your life easy when it comes to model validation. So like we said, we want this type of validation to either sit in the presentation layer or somewhere early in the application layer. So the approach that we're going to take is a common approach taken in most clean architecture structured solutions that use Fluent validation, which is creating the validators on the command objects. So for each one of the commands that needs validation, we'll create a corresponding command validator that will validate this command. Some queries may also need validators. In that case, similarly, they'll sit next to the corresponding query. And the way this works is that we'll run each one of these validators right before we execute the handler. So we get some data, it's passed to the command, we run the validator, make sure that the data is legit, and if it's not legit, then we simply don't go ahead with the logic of the handler and we return an error. So let's go ahead and implement our very first Fluent validation validator. So for us to be able to use Fluent validation, let's say .NET add, and we want to add to the application project the package Fluent validation. Once we have that, then we can go to the application layer. And let's go ahead and write a validator for the create gym command. So over here under gyms, under commands, we have the create gym command that currently only receives the name and the subscription ID. So let's go ahead and add some validations for this name property. So let's say create gym command validator, and this is going to be the following. So create gym command validator. Like we said, this needs to implement the abstract validator coming from Fluent validation, and the object that we want to validate is the create gym command. Once we have that, then we can go ahead and define a constructor that over here we have the rule for method that we can specify which property we want to validate, which in our case is the name. And over here, let's say minimum length of, 3, and maximum length of, let's say 100, okay? So now that we have this, then we can go ahead and create an instance of this validator. So going to the handler, we can say over here, var validator equals new create gym command validator. And once we have that, then we can go ahead and say validation result equals validator dot validate async, pass it the command. And of course, we want to await this over here. And then we can say validation result dot is valid. And if it's invalid, then we want to go ahead and return a list of errors based on the validation failures. So what I want us to do is put a breakpoint over here, make a create gem request, which is invalid, and see what the error looks like. So over here, we have the validation result. First of all, we can see is valid false, meaning we have some error. And then if we look at the error, then we can see we have here two things that are interesting. First thing is the property name. So we can see that the property that we tried to validate and we failed is name. And then over here, we can see the error message that already we can see that it's very descriptive. So we can also see it up here. So you can see the entire thing where the length of name must be at least 3 characters. You entered 1 character. So as you can see out of the box, we get a very descriptive error message that we can propagate back to the user. So let's go ahead and take the property name and the error message and use it to construct a list of errors to return to the user. So let's say over here, return, and then let's take the errors, and for each one of them, let's go ahead and create a new error or error. So let's say error.validation, and for the code, let's give it the property name. So let's say property name, and for the description, let's go ahead and give it the error.error message, right? So again, what we're doing is we're running the validator, converting it to a list of error or errors that we're returning in case we see that the validation is invalid. So let's go ahead, run the service again, make a request and see what we get back as the client. So let's make a request again without putting a breakpoint. And we can see over here that we get the error, which is 400, which is a bad request, which is good. And then we can see that we have the name and the corresponding error over here. If we had multiple errors, then all the errors would appear over here, one next to another in the errors dictionary over here. Now, I'm sure you're looking at this boilerplate code over here, and you're thinking to yourself, we don't really want to write this kind of code for each and every one of our handlers. So let's go ahead and take a look at mediator pipeline behaviors and how we can go ahead and integrate this validation check as part of mediator's request pipeline.